We're going to start with section 8.1, which is about basic integration rules. So the first thing we're going to do is we're going to recall some basic integrals. So the first one, the integral of x to the n, we do our reverse power rule. This is x to the n plus 1 plus c. Okay. So for example, let's say we want to integrate x squared. Well, the reverse power rule says you increase the power by 1, so it'll be x cubed divided by 3 plus c. Okay. All right, our next integration rule, the integral 1 over x dx. It's natural log the absolute value of x plus c. The integral of e to the x is e to the x plus c. The integral of a to the x, it's 1 over the ln of a to the x plus c. This one is kind of similar to the e to the x integral. Let me give you an example. Let's say we want to find the integral of 2 to the x dx. This would be 1 over ln 2 to the x plus c. Okay, so here we're using a is the value 2. Now let's move on to trig functions. The integral of sine is minus cosine. The integral of cosine is sine. The integral of tangent is negative ln absolute value of cosine x plus c. So let me expand upon this one. How do we figure out this integral? So in order to figure this out, what you need to do is you need to write tangent as sine over cosine. And then from here, you're going to do a u substitution. What should we pick for u? We're going to pick u as cosine x. The derivative of cosine is minus sine x. So when I make this substitution here, I'm going to get negative 1 over u du. And we already said the integral of 1 over u, that'll be natural log of u, negative natural log of u plus c. And then u was cosine x. Okay, so that's how you actually find that integral. Okay. The integral now of cotangent, you would do something similar, but cotangent is cosine over sine. So you'd get natural log absolute value of sine of x plus c. Okay. The next integral would be secant. You get natural log secant plus tangent plus c. And cosecant, the integral of cosecant is very similar. It's a negative natural log cosecant plus cotangent plus c. And then the integral of secant squared is tangent. The derivative of tangent is secant squared. The integral of cosecant squared is negative cotangent plus c. Okay, two more trig integrals. The integral of secant times tangent is secant. And then related to that, the integral of cosecant times cotangent is negative cosecant plus c. All right, so that's all of the trig integrals. And then the last three are the inverse trig functions. So the integral of 1 over the square root of a squared minus x squared is arc sine of x over a plus c. The integral of 1 over a squared plus x squared is 1 over a arctangent x over a plus c. And the third one, the integral of 1 over x square root of x squared minus a squared dx will be 1 over a arcsecant of the absolute value of x over a plus c. Okay. So now that we've gone over these basic integration rules, the next thing we're going to do is we're going to compute some integrals. So we're going to look at a few examples. Let's start with our first example. We want to evaluate the following integral. The integral of 4 over x squared plus 9 dx. So the first thing we're going to see is that there's this coefficient of 4 in the numerator. So what we're going to do is we're going to pull that out in front. And then this 9 is the same thing as 3 squared. Now what's left inside the integral looks like one of our inverse trig functions. So let's look back. Which one does it look like? It looks like arctangent, where a is 3 here. So you're going to get 4, and then it was 1 over a, so 1 over 3, arctangent of x over a, x over 3, plus c. Okay, so our next integral we're going to look at is something kind of similar to this last one. I'm going to make one change. Let's evaluate the integral. We'll keep the bottom the same, x squared plus 9, and now in the numerator it's going to be 4x. So if you compare this one to the inverse trig functions, this one won't match up with any of those inverse trig functions. So what we're going to do here for this integral is instead we're going to use substitution. What should I select for you? For you, you're going to select x squared plus 9, and then du will be 2x dx. So if I divide this last one by 2, I'll get 1/2 du equals x dx. So I'm going to make my substitution. I'm going to pull that 4 out in front. And then the denominator becomes u. And then what do I have left in the numerator? It's x dx, which is a 1/2 du. And you can pull that 1/2 out, so my new coefficient is 2, 1 over u. And what's the integral of 1 over u? We said earlier that's natural log of u. Plug back in. For u, it was x squared plus 9. Remember, on these, you can check your answer. If you take the derivative of your answer, you should get back what you started with in the integral. All right, let's move on to our next example. And we're going to look at a definite integral now. Let's evaluate the integral from 0 to 1 of x plus 3 over the square root 4 minus x squared dx. So to compute this integral, what we're going to do is we're going to split it into 2 pieces. So I'm going to split this up into this integral from 0 to 1, x over the denominator plus 3 over the denominator. So what we're going to do is we're going to focus in on this second integral for now. I can pull out the 3. And 4 is 2 squared. So now, if I look at my inverse trig integrals, this one matches up with arc sine, where a is 2. So this becomes 3 arc sine of x over 2. All right, so we've figured out the integral for our second integral, but now we need to figure out this first integral right here. So this one looks like we can get away with doing a substitution. So I'm going to figure out what the substitution is and compute this integral separately for now as an indefinite integral. So if we do it like this, we won't have to change the numbers here, the bounds on our integral. So here, what should my substitution be? Well, where's my composition? It's in the denominator. And the inside part would be 4 minus x squared, negative 2x dx. So you'll get a negative 1/2. The integral x dx will become a du, and the square root of u, and the denominator. So then I would move up the square root of u into the numerator. This will be the integral of u to the negative 1/2. It's negative because it was in the denominator. And do your reverse power rule now. So my new power will be add 1, 1/2, divide by 1/2 plus c. So the 2 and the 1/2 cancel. You're left with negative square root of u plus c. And I plug back in my u. So we've now figured out that first integral. So I can go back to my problem, the integral from 0 to 1, x plus 3, square root of 4 minus x squared. And so for the first integral, you had negative square root of 4 minus x squared. For the second one, we had 3 arc sine of x over 2. And then you need to plug in your bounds, which were 0 and 1. So we're going to start with the top number 1. If I plug in 1, you'll get negative square root of 3 plus 3 arc sine of 1/2. And then you're going to subtract, plug in 0, negative square root of 4 plus 3 arc sine of 0. Arc sine of 0 is 0, and arc sine of 1/2 will be pi over 6. So if we simplify, we'll get negative square root of 3 plus pi over 2 plus 2. All right, for the next example, let's find the integral of x squared over the square root of 16 minus x to the 6th dx. So looking at this integral, if you look in the denominator, you'll see that you have a composition of functions. You have an inside and an outside. And so maybe you would want u to be 16 minus x to the 6th. What would the derivative of u be then? Negative 6x to the 5th. I don't have an x to the 5th in my integral, so this substitution won't work. So if you notice, what else do I have in the integral? I have an x squared. So what that means is my substitution needs to be on x cubed. So I'm going to need to rewrite this integral as the integral of x squared over the square root 16 minus, this will be x cubed squared. And from here, I can now do my substitution. My u would be x cubed, my du would be 3x squared. So I need a 1/3. And I'm ready to make my substitution here. So x squared dx, I'd get 1/3 du, 1 over the square root of 16 minus u squared. And now this looks like one of our inverse trig integrals. I'm going to write this as the integral of 1 over the square root of 4 squared minus u squared. And which inverse trig does this look like? It looks like arc sine. So this will be 1/3 arc sine of u over 4 plus c. And then you just have to substitute in u. U is x cubed. So this will be 1/3 arc sine of x cubed over 4 plus c. Okay, our next problem we're going to do, let's look at evaluating the integral 1 over 1 plus e to the x dx. So what could we do here? We could use substitution. And what would you want u to be? Well, u could be e to the x, or it could be 1 plus e to the x. All right, so in either case, should go with u being 1 plus e to the x. du would be e to the x. So I need another e to the x in my integral, and I don't have it. So this substitution won't work currently. So what we're going to do is we're going to take our integral, and I'm going to rewrite it. I'm going to change the numerator a little bit to e to the x minus e to the x. Well, really, I didn't actually change the numerator because e to the x minus e to the x, that's 0. So I haven't changed anything. But what this allows me to do is I can now split this up into two pieces. I can split it up as the integral of 1 plus e to the x. And then the integral of negative e to the x, 1 plus e to the x. And if you look in that first fraction, the numerator and denominator are the same. So they cancel to become 1. And I'm going to go ahead and pull out the minus from the second integral. What's the integral of 1? Well, you get x back. So for this other integral that we're left with, we can now do substitution for this integral. My u would be 1 plus e to the x. du would be e to the x dx. And so I can plug in my substitution here, x minus the integral 1 over u du, and we've integrated 1 over u a few times now, minus ln of u plus c, and plug in u was 1 plus e to the x. And there's our answer. So we've got two more integrals that we want to compute now. So let's start with our next one. Let's find the integral of cotangent times natural log of sine of x dx. So what we want to do is we want to use substitution here. So what should the substitution be? Take a minute and make a guess. What should I try? What should I select for u? Usually when you're doing substitution, you look for your composition part of your integral. So here's where I have a composition, and you would let u be the inside part. So what happens if I let u be sine of x? What's the derivative? Cosine x dx. And I don't have a cosine x, I have a cotangent x. So what this tells me is maybe this substitution isn't going to work out. I should have tried something else. So let's try instead now using that whole composition, ln of sine x. And what's the derivative of this? You have to use the chain rule. So 1 over sine x. And what's the derivative of sine? It's cosine. So this is the same thing as cosine over sine, which is cotangent. And remember that we do have a cotangent in our integral, so this substitution should work. Okay, so the integral of cotangent ln sine x dx, this will now become the integral, this ln sine x, that all becomes u, and then this cotangent x dx becomes du. So now we're integrating u, which is just the reverse power rule, u squared over 2 plus c. And now plug in for u. U was ln of sine x squared plus c. Okay, let's do one last integral. Find the integral of tangent squared of 2x dx. Here I have a composition. Let's try a substitution here. Let's let u be 2x. And if you solve for dx, 1/2 du equals dx. So we're going to compute the integral, tangent squared 2x dx. Let's do our substitution now. So you'll get tangent squared u, and you'll get a 1/2, which I'm going to go ahead and pull out in front, du. Now, do we know the integral of tangent squared? And the answer is no. I don't know of a function whose derivative is tangent squared. So what we're going to do is we're going to use an identity. And what's that identity going to be? So sine squared plus cosine squared, this is going to be equal to 1. And what I'm going to do is take this equation and divide everything by cosine squared. So sine squared over cosine squared becomes tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. And if you solve for tangent squared here, you get secant squared minus 1. So in my integral, I'm going to replace tangent squared by secant squared minus 1. And I do know the integral of secant squared. It's tangent. The integral of 1 is u plus c, and then all we need to do is plug in what our u was. Our u was 2x. 1/2 tangent of 2x minus 2x plus c. And you can distribute that 1/2 if you would like, but you don't have to. So let's kind of review what we went over. We mainly spent a lot of time talking about substitution. And the goal with substitution is it should take a complicated integral and make it look a lot nicer and a lot easier. So one thing I do want to mention is that when you do your substitution, be very careful and make sure that you're only using one variable for your integral. So you only have x's in your integral or only have u's in your integral. You can't have both x and u in your integral because they're related to each other. Okay. All right, if you need more help with substitution, a resource I would look at is a website called Paul's Online Notes. They have a few example problems that you can work through on substitution that should kind of refresh your memory on what substitution is.